Welcome to topic 4501. This presentation introduces urban resilience assessment frameworks and metrics. The goal is not only to define resilience, but to show how planners can actually assess it in ways that support action. Across the session, we connect core concepts, such as resilience, vulnerability, and adaptive capacity, to practical tools that cities use to diagnose weaknesses, compare performance, prioritize investment, and monitor change over time. The presentation is introductory, but it is also rigorous. We will distinguish conceptual frameworks from indicators, metrics, and composite indexes. We will also show that resilience assessment is never neutral. It depends on the system being studied, the scale of analysis, the hazards considered, the data available, and the values built into the measurement process. Finally, we use applied examples, including the Madrid region, a 6-city comparative index, and Qingdao, to show how these ideas become measurable in real planning practice. The presentation moves in a clear sequence. First, we ask why urban resilience should be assessed at all. Second, we define the key concepts of resilience, vulnerability, and adaptive capacity. Third, we introduce a simple but powerful framing device, the 5W questions. Resilience for whom, for what, to what, where, when, and why. These questions help prevent vague or one-size-fits-all measurement. Fourth, we distinguish between frameworks and metrics, then review three main families of assessment: scorecards, indicator dashboards, and composite indexes. After that, we discuss how indicator systems are built, how composite metrics are produced, and why multidimensional evaluation matters. The second half of the presentation applies these ideas through three case examples, then connects assessment to scenario thinking and planning strategy. We end with limitations, ethics, and a concise set of takeaways for resilience-oriented urban development. This topic is structured around 5 learning outcomes. The first is conceptual knowledge, explaining the basic concepts of urban resilience, vulnerability, and adaptive capacity. The second is methodological knowledge, identifying major resilience assessment frameworks and commonly used metrics in urban planning. The third is an applied skill, analyzing urban systems with basic indicators to assess vulnerability and adaptive capacity. The fourth is a planning skill, developing simple resilience scenarios and proposing appropriate strategies. The fifth is an attitudinal outcome, recognizing why resilience-oriented thinking matters in sustainable urban development. These outcomes are cumulative. Students first learn the language of resilience, then the tools, then the analytical logic, and finally the planning relevance and ethical awareness needed to use these tools responsibly. Cities are complex systems of systems. Infrastructure networks, ecological processes, social conditions, governance arrangements, and economic activities all interact. Because of this complexity, resilience cannot be managed through intuition alone. Assessment helps translate complexity into tractable evidence for decision-making. A resilience assessment can establish a baseline, show how performance changes over time, identify which subsystems are weak, and support prioritization of interventions and investments. It can also improve coordination across sectors by making trade-offs more visible. For example, a city may appear economically dynamic but remain vulnerable because its infrastructure is fragile or because social inequality undermines recovery capacity. Assessment therefore supports planning, budgeting, monitoring, and accountability. Importantly, metrics are not the goal in themselves. Their value lies in helping public institutions move from a broad ambition, such as becoming more resilient, toward specific, evidence-informed actions. In teaching terms, this helps students see that resilience assessment is not a technical afterthought. It is part of the planning cycle itself because it links diagnosis to choices about sequencing, targeting, finance, and monitoring. In practice, assessment can also strengthen institutional memory by giving cities a structured way to document where vulnerabilities are concentrated and whether earlier interventions changed conditions. 3 concepts sit at the center of urban resilience assessment. Resilience refers to the ability of an urban system to withstand shocks and stresses, recover from disruption, and adapt while maintaining essential functions. Vulnerability refers to susceptibility to harm, often shaped by exposure and sensitivity. Adaptive capacity refers to the ability to adjust, learn, reorganize, and transform in response to change. These terms are related, but they are not interchangeable. Vulnerability helps reveal where and why harm is likely. Adaptive capacity focuses on the resources, institutions, knowledge, and flexibility that make adjustment possible. Resilience is the broader system-level outcome that depends partly on both. In practice, many assessment frameworks operationalize these ideas as measurable capacities, such as resistance, recovery, preparedness, redundancy, flexibility, or learning ability. A strong introductory understanding depends on keeping the distinctions clear while also seeing how they work together in an assessment framework. Before selecting any indicator, planners need to define the assessment context. A useful way to do that is through the 5W questions. First, resilience for whom? This asks who benefits from resilience and who bears risk, bringing equity and distributional issues into view. Second, resilience for what? This defines the system or function of concern, such as housing, water supply, mobility, health services, or local livelihoods. Third, resilience to what? Cities face different shocks and stresses, from floods and heat waves to economic downturns, pandemics, and infrastructure failures. Fourth, where? Scale matters. A citywide score can hide neighborhood-level hotspots, while corridor-level infrastructure analysis may miss broader social effects. Fifth, when and why? A short-term emergency response assessment is different from a long-term transformation-oriented assessment. These questions are crucial because changing any of them changes what good performance looks like and therefore changes the indicators that should be chosen. A common source of confusion is the difference between frameworks and metrics. A framework is the conceptual structure that defines what resilience means in a given assessment. It identifies relevant dimensions, capacities, or subsystems. A metric is the operational side, the indicators, scores, dashboards, or composite indexes used to measure those dimensions. In a well-designed assessment, the framework comes first. It clarifies what matters and why. Then an indicator system specifies what will be measured and where. Metrics convert those measurements into forms that can be interpreted, benchmarked, and used in decision-making. This sequence matters because poor assessments often jump straight to numbers without a defensible conceptual basis. Good assessments document assumptions, explain why indicators were selected, and show how results should be interpreted. In other words, the framework gives meaning to the metric, and the metric gives practical form to the framework. Urban resilience assessments often fall into three broad families. The first is the scorecard or checklist approach. This is usually stakeholder-friendly and useful for governance or institutional self-assessment, but it is often qualitative and less comparable across places. The second is the indicator dashboard. Dashboards present multiple indicators side by side and are often strong for diagnostic work because they show subsystem performance transparently. Their weakness is that they can be difficult to summarize for communication or high-level comparison. The third is the composite index. A composite index aggregates multiple indicators into a single score or a smaller set of scores. This can support ranking, tracking, or communication, but it introduces challenges related to weighting, aggregation, and hidden inequality. None of these approaches is universally best. The appropriate choice depends on the assessment purpose, scale, data availability, institutional capacity, and the assumptions defined earlier through the 5W questions. Several well-known tools help illustrate how resilience assessment is practiced. The City Resilience Framework and related City Resilience Index provide a holistic, capacity-based lens for understanding resilience across multiple urban dimensions. The UNDRR Disaster Resilience Scorecard for Cities supports self-assessment and action planning, especially in relation to disaster risk reduction and the Sendai framework. ISO 37123 provides standardized definitions and methods for indicators for resilient cities, helping with consistency and comparability in reporting. These tools differ in emphasis. Some are stronger for dialogue and governance, some for self-assessment, and some for standardized measurement. The main lesson is not that there is a single best tool, but that planners should match the tool to the decision context. A city that needs broad stakeholder dialogue may choose differently from a city that needs systematic reporting or a city that wants to construct a more detailed composite index. Most resilience assessments organize indicators by dimensions or subsystems. Typical categories include economy, society, ecology, and infrastructure, although some frameworks also add governance, institutions, or culture. This system view is important because resilience is produced through interactions, not by any single sector alone. When building an indicator system, several rules of thumb help. Indicators should match the 5W framing and the actual levers of decision-making. They should be measurable, interpretable, and directionally clear, meaning that users understand whether higher values indicate better or worse resilience. Because some capacities, such as governance quality or social cohesion, are difficult to capture quantitatively, mixed methods are often necessary. Finally, equity must remain visible. Averages can hide hotspots and vulnerable populations. For that reason, a well-designed indicator system often combines quantitative data with qualitative insight, spatial disaggregation, and stakeholder interpretation. This is why indicator design is partly a planning exercise. It forces analysts to ask which signals are actually useful for intervention and which are merely available data. Building a composite resilience metric usually involves a sequence of steps. First, define the system boundaries and essential functions. Second, select indicators that reflect the conceptual framework and available data. Third, normalize the indicators so that different units can be compared. Fourth, assign weights. Fifth, aggregate the data into a composite score or set of scores. Sixth, validate the result through sensitivity checks and comparison with on-the-ground knowledge. Every stage involves choices, and those choices are not purely technical. Weighting, for example, embeds value judgments about what matters most. Aggregation may simplify communication, but it can also hide inequality or compensate for one weakness with an unrelated strength. Rankings can change significantly if methods or datasets change. This is why transparency matters. Good practice is to pair headline scores with subsystem dashboards, hotspot maps, and explanations so that a composite metric supports interpretation rather than replacing it. Sensitivity checking is especially important in resilience work because small methodological changes can produce large interpretive differences, and those differences may affect policy priorities. Green infrastructure is a useful example because it shows why resilience assessment often has to be multidimensional. A narrow metric might count only the amount of green space, but resilience outcomes depend on much more than that. Policy adoption matters because rules and incentives shape implementation. Performance matters because green infrastructure affects ecosystem services, thermal regulation, stormwater management, or habitat quality. Connectivity matters because the movement of people, water, and species depends on the spatial relationships between green areas. Social cohesion matters because participation, stewardship, and local acceptance influence long-term effectiveness. The key lesson is that resilience often emerges from interactions across dimensions rather than from one isolated indicator. This reinforces the value of multidimensional dashboards and mixed method evaluation. It also reminds planners that a technically attractive intervention may underperform if its governance, social uptake, or connectivity conditions are weak. In other words, a resilience assessment that ignores these interactions may underestimate both opportunities and constraints. The Madrid region case illustrates a holistic, indicator-based framework for assessing urban resilience. The key contribution of this approach is that it organizes multiple dimensions of urban systems into a composite structure that can support baselining and comparison across places. In planning terms, this is useful because it helps decision-makers see relative strengths and weaknesses and identify spatial hotspots. At the same time, the case also teaches caution. Composite indexes are only credible when indicator selection, weighting, aggregation, and interpretation are transparent. Maps and dashboards can reveal important spatial patterns, but comparisons must remain like for like. Municipalities differ in context, resources, and system boundaries. The Madrid example is therefore valuable not because it gives a universal formula, but because it shows how a regional resilience index can be designed as a planning support tool when it is carefully documented and interpreted with contextual awareness. The comparative six-city example extends the logic of composite measurement across regions and time. In this case, a comparative urban resilience index was applied to 6 cities in China, Europe, and the Americas, with results compared across 2 time points. The strength of this approach is that it can highlight which dimensions are changing over time and can identify examples that appear relatively stronger in particular categories. This is useful for benchmarking and for identifying where further investigation may be needed. However, cross-city comparison is always risky if contexts are treated as directly equivalent. Data consistency, indicator definitions, system boundaries, and timeframes all affect the credibility of comparison. The main planning lesson is that comparative indexes can support learning and diagnosis, but they should not be read as simple league tables. They are most useful when they prompt deeper, contextual interpretation rather than superficial competition between cities. The Qingdao case is especially useful because it links measurement directly to strategy. Its index structure includes 4 dimensions: economy, society, ecology, and infrastructure, and 3 attributes: resistance, recovery, and adaptability. The study tracks resilience over time and then uses obstacle diagnosis to identify which dimensions are holding performance back. In the presentation, the high-level takeaway is that overall resilience increased over the study period, while infrastructure emerged as a key obstacle factor. The methodological value lies in the logic of measure, diagnose, and prioritize. Rather than stopping at a score, the assessment asks which subsystem is constraining improvement and how planning should respond. This makes the case highly relevant for practice. It shows that resilience metrics are most useful when they help direct attention toward bottlenecks, inform prioritization, and support targeted enhancement strategies rather than simply describing conditions. Assessment becomes more useful when it feeds into scenario thinking. A simple way to do this is to combine hazard intensity with adaptive capacity. If hazard intensity is low and adaptive capacity is strong, the system may be robust and adaptive, meaning it can maintain service and learn. If hazard intensity is high but adaptive capacity remains relatively strong, the system may be stressed but recovering, so planners may focus on recovery capacity. If hazard intensity appears low but adaptive capacity is weak, there may be hidden vulnerability that requires closer monitoring. If hazard intensity is high and adaptive capacity is weak, the city faces high risk and needs investment to reduce vulnerability and build capacity. To construct such scenarios, planners can select a shock or stress, identify vulnerable functions and groups, define plausible levels of capacity using indicators, and then propose strategies. This is a simple but powerful bridge between assessment and planning action. Even when the scenario model is simple, it is valuable because it makes assumptions explicit and helps teams discuss strategy under uncertainty instead of waiting for perfect prediction. That matters in planning because decisions are often made under incomplete information, so even a basic scenario matrix can help teams compare response options, identify no-regret measures, and communicate priorities to stakeholders. Urban resilience metrics are never neutral. They embed judgments about what counts as resilient, whose resilience matters, and which losses are visible or invisible. Aggregation can hide inequality and local hotspots. Data gaps can bias results, especially when social vulnerability must be represented through proxies. Comparisons require consistent boundaries and comparable contexts, which are often hard to achieve in practice. Because of this, resilience measurement should be treated as a conversation starter rather than a final answer. Mixed methods are important. Quantitative indicators should be interpreted alongside local knowledge, stakeholder input, and qualitative understanding of place. The question resilience for whom is especially important because it forces planners to confront distributional impacts and ethical trade-offs. A city can become more resilient on average while some groups remain exposed or excluded. Responsible resilience assessment therefore requires transparency, reflexivity, and an explicit commitment to equity. The most useful resilience assessments are those that can be converted into action. The Madrid region example shows how index-based baselining can support comparison across municipalities, guide program targeting, and monitor change over time. The Qingdao case shows how measurement combined with obstacle diagnosis can identify weak subsystems and support targeted strategies. Taken together, these cases suggest a repeatable workflow for planning practice. First, define the purpose through the 5 Ws. Second, choose a framework and design an indicator set that matches decision levers. Third, combine a headline metric with diagnostic outputs such as dashboards and maps. Fourth, translate results into strategies, priorities, and monitoring arrangements. This workflow reinforces a practical point. Resilience assessment is not merely an academic exercise. When designed well, it can structure dialogue, reveal priorities, justify investment, and support iterative learning in urban and regional development. It also encourages institutional learning because repeated assessments can show whether earlier interventions actually improved system performance or merely shifted the problem elsewhere. The key message of this topic is that urban resilience assessment is most valuable when it is purposeful, transparent, and tied to planning action. Start with the 5 W's so that the assessment is explicit about whom it serves, what system it addresses, what shocks matter, what scale is relevant, and why the exercise is being done. Then choose an approach that matches the purpose and the capacity of the organization. A scorecard, a dashboard, a composite index, or a combination of these. Design indicators across subsystems, keep equity visible, and be explicit about assumptions related to data, weighting, and aggregation. Use case studies and scenarios to move from diagnosis to strategy. Above all, remember that resilience metrics are tools for action and learning. They help planners ask better questions, see patterns more clearly, and make more defensible decisions, but they should never be mistaken for the full reality of urban resilience. That is the foundation of resilience-oriented planning practice at the introductory level. For students and practitioners alike, this means resilience assessment should be seen as an iterative cycle of framing, measuring, interpreting, acting, and learning.